it serves somewhat the standardization of our point estimators. Yeah. So basically, what you have here in the denominator is something like the variance of the alpha 1, the variance of alpha 2, plus twice the covariance between alpha 1 and alpha 2. Yeah? So that's why, again, we have to take account the correlation between these two parameter estimates, so if we test them jointly. So that's why, obviously, this is a part that basically enters here in the denominator of our equation. Yeah? Okay. Now the last question arises. So let's assume we want to test, instead of the alphas here, we want to test if our exposures, our beta exposures of our assets here, of what is on the left hand side, if they are simultaneously different from zero. So basically what we're interested in, let's say we want to test if the regressor here, our market factor or whatever we have here as a regressor, if our regressor is, or if our assets here on the left hand side have a significant exposure, if they are significantly, let's say, correlated with the regressor. So in this case, we would test them jointly in this multiple equation model. So we would basically, instead of the alphas, we would test beta 1 and beta 2 simultaneously. So the only thing, what we have gone through, nothing changes. The only thing, apart from one thing, so our R, we need to redefine our R, small r. We know earlier it was 1, 0, yeah, because it depicts basically the corresponding estimate in each equation that we are interested in testing. So now it's obviously the second guy in our equation. It's on the second position, it's the second parameter. So obviously we just have to rewrite it as 0, 1. Once we define our small r as 0, 1, we can just implement all the other things that we have now been talking about, and our chi-square test here, our lambda, would give us then basically the corresponding values here for our beta 1 and beta 2, okay? Beta 1 and beta 2. Yeah. That's basically what I would have liked to gone through in this context of seemingly unrelated regression technique. So as I said, so once again, this is the simplest case if we have just two equations and one regressor, and of course we can expand the model. We can have either more regressors here, if we have a different vector model, or we can have more equations. This is the simplest case. As again, Farmer and French papers, they usually use 25 test assets sorted by different characteristics, and they run this test many times, for different sort of test assets. So, and in the term paper, probably you will be dealing with cryptocurrencies, and you might be supposed to implement this test for a whole bunch of cryptocurrencies. So what we will do next is we will talk about another technique, another methodology that is usually used in asset pricing research and finance, and it's called Farmer-Macbeth regressions.